In this video, I'll be talking about indefinite integrals. More specifically, we're just going to be introducing to indefinite integrals using the reverse power rule. That's the easiest one to do integrals with, easiest rule at least. So what the reverse power rule is basically for derivatives, you have a power rule. For integrals, you also have a reverse power rule. And the reason why I use the reverse power rule is because for integrals, another name for it is the antiderivative. Technically, an integral is the reverse of a derivative. An integral is an antiderivative, the reverse of it. So what I mean by that is if you took the integral of some function, you would get a resulting function, usually represented by capital F for an integral, plus some arbitrary constant. And when you take the derivative of this new function, you get the original function. So what do I mean by this? Well, if you take the derivative of an integral, you take the dx, and you take the derivative of your function, what you actually get, I tried to pick my eraser tool there. What you actually get is the original function. So the derivative cancels out the integral, so you just get f of x. And if you take the derivative of your integral, then you also get f of x. So the derivative of your integral is equal to your original function. And if you take the derivative of some integral as well, it cancels out the integral symbol and the dx symbol as well. So now that you know that, you kind of have to imagine that you have to think in reverse now. You learned derivatives. Hopefully you're familiar with power rule by now. But now you have to think about integrals as the reverse of derivatives. So you have to think kind of backwards. You know, it's a lot easier to understand what area under the curve is than instantaneous slope. I guess the concept of an integral isn't as bad as derivatives. So if you really understand derivatives, you're gonna get integrals. You're gonna learn how to find the indefinite integral real fast. So before I actually go into some problems and show you the reverse power rule, I have to talk about the arbitrary constant. So the plus c. When you take an indefinite integral, you must put the plus c. I lost so many points on my first integrals test off of missing this plus c. You have to add the plus c whenever you're taking an indefinite integral. So indefinite integral just gives you a function. You don't have bounds like b or a or nothing like that. That's called a definite integral. That's another video. But you have to add the plus c. And you might be wondering, why is there a plus c? Well, since I was talking about derivatives, if you take the derivative of your function, your integral, capital F, and you have a constant here, well, what the derivative does is actually cancel out the constant. So if the derivative of your integral, or capital F, is equal to the original function, well, when you take the derivative of this, you kind of miss out on some constant. And no matter what you do with this new function, this original function f, if you take the integral of it, you're never going to get that arbitrary constant back again. So if you take the integral of f, you're just going to get f of x, never knowing what plus c is unless you get a point on the graph. But yeah, you'll probably get a question on an exam about that, honestly. But now let's actually talk about the reverse power rule. So this is the reverse power rule, if you want to see it in numbers. So if you want to take the integral of some function x to the power of n, then your integral looks like this. 1 over n plus 1 times x plus n plus 1. So if you want to take the integral of x to the power of 3, dx, well, since n is equal to 3, we do 1 over 3 plus 1, which is 4, times x to the power of n plus 1, which is also 4. Right? N is 3, 3 plus 1 is 4. Well, what we get is actually, if we make this look simpler, x to the power of 4 over 4. Now, if you take the derivative of x to the power of 4 over 4 using power rule, you actually end up getting x to the power of 3. So the thing about the inverse power rule is, again, it still applies the same concept of your derivative of your integral is your original function. So the derivative of this calculated integral here is the original function. And I'm going to preach what I say, put the plus c. I almost forgot about that. Let's go ahead and solve for the integral of this function. And keep in mind, get really familiar with integrals, because you're going to be using this for the entirety of your career in calculus. Oh, boo-hoo, poor you. Especially if you're an engineer. Good luck. So this is what you have as your inverse power rule, right? And basically, n is the original exponent. So right here, what we can actually do, just like we can do for derivatives, is separate all the terms. So if you have a plus or minus, you can separate the integrals or the derivatives into different things. So 3dx. And we can calculate each of these integrals individually and then add them up or subtract them at the end when you calculate all of everything. So we have 5x to the power of 4. Well, x to the power of 4, n is equal to 4 in this case. So what we should do is get rid of the coefficient. So let's ignore the coefficient for now. 5, right? And we have x to the power of 4. N is equal to 4 in this case. And if we use the power rule form, inverse power rule form, we should get 1 over 5 times x to the power of 5. All right, now that we have that, go ahead and calculate this next thing. 9 times x to the power of 2. Well, we can get rid of the coefficient. We can take, just like derivatives, we can move the coefficients outside the integral. So if I wanted to, I could put the 5 here outside the integral and just erase the 5 inside. But I'll keep it inside. But now we have x to the power of 2. And n in this case, or the exponent, is 2. So all we need to do is multiply this by 1 over 3, right? 2 plus 1. And then multiply this by x plus 3. X to the power of 3, sorry. Next thing, we have a 3. We can technically move the 3 out, but it's like the only term inside of this integral. So really, if you see just a whole number, if you want to take the integral of it, just put an x in front of it. Okay, but if you wanted the power rule form, technically 3 is equal to x to the power of 0. X to the power of 0 is equal to 1, right? So since x to the power of 0 is equal to 1, then that's why you just get a 3. 3 times 1 is just 3. But if you have x to the power of 0, that means n is equal to 0. And if n is equal to 0, then you would get 1 over 1 in this first term. And then you get 0 plus 1, which is just x to the power of 1. And 1 times x to the power of 1 is just x. And that's where you just get the x from in 3x, using power rule for your constants. So if you see some constant, you want to take the integral of it, just multiply by whatever variable you're integrating with respect to. And in this case, we're integrating with respect to x, hence the x after the dx. And arbitrary constant, never forget that. But if we wanted to simplify this, what we would get is, well, the 5 cancel out from here. So we would get x to the power of 5 plus 9 over 3, which is just 3, x to the power of 3 minus 3x plus c. And a great way to check if your indefinite integral is right is by simply taking the derivative of your function again and then seeing if it equals the original integrand. This is called the integrand. The function inside the integral is called the integrand. Let's go ahead and find the indefinite integral of the square root of x minus 4. So what we can do, again, we can separate the terms into separate integrals. And we already know the integral of some constant. This is just 4x. Okay? But x to the power of 1/2, or x square root, is a little more tricky. So what we do here is we recognize that the exponent is 1/2. So we add 1/2 onto 1. That means we get 1 over 3 over 2 times x to the power of 1/2 plus 1, which is 3 over 2. And what we can do is actually flip. We can actually just flip this fraction around to get 2 over 3 times x to the power of 3 over 2. 1 over 3 over 2 is equal to 2 over 3, using a little bit of arithmetic. But basically, what we have here is the integral of square root of x. 2 over 3 to the power of 3 over 2 plus c. Now the thing about this integral is there's going to be fractions, and a lot of your integrals are going to have fractions. The last one just looked pretty. But again, if you want to check if your integral is right, literally just take the derivative of it, and if the derivative of this is equal to your integrand, then your integral, or your definite integral, is correct. So if you've made it to the end of this video, I'm just going to explain a little bit more than I need to related to definite integrals now. So I'm just going to introduce a little bit of definite integrals into an indefinite integrals video. But basically what an indefinite integral calculates is area under the curve, right? So whatever input you put as x, so the integral of x is x squared over 2. Whatever value you put into x, or your integral, like let's say we make the input 2, that will be, and the output will be the area under your integrand. There you go. Integrand is the, remember, the function inside your integral. So if I plug in 2 into here, right, that means that at x equals 2, between 0 and 2, the area under the curve is equal to 2 to the power of 2 over 2, which is 4. So 2 to the power of 2 over 2 is, 2. Now, the thing about calculating definite integrals is that you can ignore c. And I'll cover that more in depth in my actual definite integrals video. But basically, for the indefinite integral, whatever you put as the input will be the area under the curve between 0 and your input for your integrand. So if I put a 2 here, we get the area under the curve from 0 to 2. The reason why this works out is because for function x equals y. That means the height of this is equal to, let's show you this. The height of this is equal to y, correct? And the width of this is equal to x. Well, if x is equal to y, then we can replace y with x. What we can actually do here is multiply x by x to get the area of some square. So if we multiply x times x, which is just x squared, we get the area of the square. But if we divide the area of the square in half, we get the area of the triangle. And looky here. We get the same exact formula you get for your integral. So this is another way why integrals are so fascinating. How in the world did anyone come up with this? Why would how did you, what was Isaac Newton doing when he came up with this? But anyways, if you have any questions, put it down in the comment section. And if you found this video helpful, consider subscribing and liking the video. Thanks for watching.